Okay, so several of you have emailed me and asked for some extra practice from Chapter 8. So I have been sending out these two problems as a response to those emails. And so I just decided tonight that I was going to work them out and give you an opportunity to check. If you haven't already worked the problems, because maybe you didn't ask for extra problems, I would encourage you to stop the video, work out the problem, and then check yourself based on what I'm going to do. Just keep in mind that there's a huge difference between watching me work a problem and you being able to work it independently correctly. So you do want to get that practice in of working the problem by yourself before you look at the answer key. Okay, so for this first one, there are two problems. So for this first one, it says a builder claims that the average area of houses in a new subdivision is, and I'm going to sort of key in right here on this word, is more than 2,000 square feet. The standard deviation of the population, okay, so this is also pretty important as I start working the problem, because this tells me that as I work the problem, that I'm going to be using a z-score. Okay, remember, anytime you have the standard deviation of the population given, you use a z. If you have the standard deviation of the sample given, you use a t. All right, so it says a recent study of 27 houses showed that the average home size was 2,034 square feet. Test the builder's claim at an alpha value of 0.05. Okay, so first thing I'm going to do is I'm going to take this keyword more and I'm going to write a hypothesis for it. So it says that the average, so that's the symbol here, that's the symbol for average, it's a U, it's a Greek letter mu. All right, so the average area of houses in a new subdivision is more than, so I'm going to use the greater than 2,000 square feet. Okay, now if you have watched the lecture videos, I've stressed in those videos that if your statement has an equal sign in it, then it would be the H0 hypothesis. If it does not have an equal sign in it, then it would be an H1 hypothesis. So this one, because there is no equal sign when I wrote it, needs to be the H1 hypothesis. Okay, this one is also the claim, because that first sentence says the builder claims that the average is more than 2,000. Okay, so you want to get all of that down for H1, and then we want to go in and write the H0 hypothesis. So the H0 hypothesis most typically has just an equal sign in it. So we would write that the average is equal to 2,000. And that's coming from the definition for the null hypothesis. The null hypothesis says that there's no difference between the two values. And saying that there's no difference is saying that they're the same or that they're equal. All right, so that's why we use the equal sign for the null hypothesis. All right, so that is step one of the process. Write the hypotheses, identify the claim. Step two is to come up with your critical values. So this is where you're going to draw a curve. And you are going to decide how to shade this curve. Again, if you've been watching the lecture videos, you know that you need to shade based on the H1 hypothesis. So if the H1 has a greater than in it, you are going to be shading on the right tail of the curve. So this is where we're seeing a significant increase in our value. Now, I already know that this is a z-score, so I need to work at finding that z-score that separates shaded from unshaded in part 2. All right, so they tell me that the alpha value is 0.05. Remember that when they say that alpha is 0.05, they are giving me the area of the shaded region. Alpha is the area of the shaded region. Now, in order to find the z-score, remember that you have to have the value, the area between 0 and z. Okay, so z sits right here. So in order to use my table, I've got to know this part of the curve. So I'm going to come off to the side somewhere and I'm going to take 0.5, which is the total of the right-hand side. I'm going to subtract off the shaded region, and that will leave me with the area of the part where I put the question mark. Okay, so I'm going to go in and kind of fix this just a little bit. All right, so I'm going to put the 0.45 right there. And I'm going to tack on a couple of extra zeros just to sort of remind myself that it's an area that we're talking about there. Okay, so now I'm going to go to my table. Now, there's been some confusion about this. You have to use the table that's provided in the lecture notes. So if you don't have that table printed out, I would strongly encourage you to print a copy. I can't imagine trying to work this problem with it on a screen because I really have to line up my fingers on the paper in order to get to the right number. It's so easy to make a mistake if you're looking at it on your computer screen. So try to get a printed copy of that table so that you can work with it. All right, so I'm going to go in the middle of the table and I'm going to look for 0.4500. Now, that number is not there, but what I can find, and I'm going to write them up here at the top, I can find 44.95. And then the next one is 45.05. And so my number, 4,500, sits dead in the center between these two numbers in the table. And so our rule is that if we have a value that's not in the table, that we're going to go with the closest number. But if it's not closer to either one, because it sits right in the middle, we're going to go with the bigger one. All right, so my bigger value right here is the one I'm looking at. And I'm going to go back to my table and look up the z-score that goes with that. And that z-score will be 1.65. Now, if you're using the right table, this is what you get. You get 1.65. You don't get 1.495 or one. I've seen some different things coming in on the quizzes. Those numbers are not coming from the table that we're using. I'm not sure exactly where that number is coming from. But you want to be sure that you are on the right table. Okay, this is the standard normal distribution table. And be sure that you are looking up the right value. It should be 1.65. All right, so that takes care of step 2. All right, step 3, we're going to plug into our formula. Remember, your formula is the value that you want to convert minus the mean of the problem divided by the standard deviation divided by the square root of n. Okay, so the value that you want to convert is the value in the research that was done. So it says a recent study of 27 houses showed that the average was 2,034. So that number goes first. And then the mean is the 2,000. Now, sometimes this is a problem. Students switch these two numbers around. The best thing that I can tell you, and I say this in my class, and I probably said it in the lecture notes as well, is that this number in the hypotheses should be the second number in your formula. All right, those two should match, and that should always be the case. It is very rare that I see a student put the wrong number in the hypotheses. So if you will check your hypothesis and say, oh, it has 2,000 in it, that needs to be the second number in my formula, then you will be on the right track with that. All right, so let's get rid of this, clean that up a little bit. Okay, all right, so I'm just going to leave it. All right, so standard deviation. It said that the standard deviation of the population was 39, and the sample size was 27. All right, so now I'm going to go to my calculator with this, and I'm going to plug it in. All right, when you plug it in your calculator, remember that you really need a parenthesis around the top part and a parenthesis around the bottom part. Okay? All right, so if you have your calculator, let's check. I'm going to put it in. This is the kind of thing that if you are plugging this thing in your calculator and you're not getting the right answer, you could take a quick picture of what you're putting in your calculator and email me that picture and let me look at it, because you're probably making a mistake somewhere in terms of how you're typing it in. All right, so I'm getting, and I always type mine in twice into my calculator to make sure that I don't make a mistake. I got 4.53 when I rounded it to 2 decimal places. All right, so 4.53. All right, so that takes care of step 3. I'm going to go to my curve, and I'm going to mark that off. All right, so 4.53 is going to be way over here somewhere. Definitely on the other side of 1.65. Remember that you're comparing it back to 0. So those are the 2 marks that we're looking at when we start making our conclusion. All right, so step 4, you're either going to say reject the null or do not reject the null. All right, and it's based on your 2 marks that you just made on your curve. So those 2 marks are far enough apart to be considered significantly different. All right, remember that if your mark is in the shaded region, that you are saying that the 2 marks are different. So what we're saying here is that 2000 and 2034 are significantly different averages. All right, now remember the null hypothesis says that they're equal. Okay, that's what we wrote up here with the null hypothesis. We're saying they are equal. And what we're saying when we work the problem out is that they're different. So I am going to reject the null. Okay. All right, and then I need a conclusion. All right, so this is also something that I'm seeing as being a little bit of a problem. All right, so when I'm looking at your work that you're submitting in the quizzes, I'm seeing a lot of different phrasing on that conclusion. So I'm going to stick it up here. So you have a chart in the lecture notes for 8.1. You have a chart that you are using to write this conclusion. All right, you need to be sure again that you have access to that chart as you're working these problems, because it's going to tell you exactly what to write here. All right, so we're looking at this problem and we're saying that our claim is H1. I need to know that to use the chart. All right, I also need to know what I did in step 4. So I said that I'm going to reject the null. So I'm going to take those 2 pieces of information. I'm going to go to that conclusion chart that I have in my lecture notes, all right, and I'm going to write my conclusion. So I'm going to say there is enough evidence to support the claim. Now, this part of the sentence shouldn't change because you're pulling it off of that table. So you shouldn't have different wording here. And when you start writing it with different words, you change the meaning a little bit, I think, unintentionally. So pull it directly from that chart, okay? There is enough evidence to support the claim, and then you're going to finish the sentence. Now, this part may be a little bit different from one person to the next, all right? But the claim is that the average, all right, and you can kind of abbreviate here as much as you want to. So we're talking about area. So we're talking about average area of houses in a new subdivision. I'm not going to write all that down. I'm just going to write average area, okay, is more than 2,000 square feet. And I'm not even going to write the square feet. I'm just going to say is more than 2,000. So you want something along those lines for your conclusion. And again, the beginning of that conclusion should be identical to what I just wrote. All right, so that completes that first problem. And again, what I would encourage you to do is have worked it out, and then if there is something that you're not clear on, you need to email me and ask. Okay, if there's a particular part and you're saying, hey, I'm not getting that, send me an email and ask what questions you need to ask, because you need to be able to work these problems. All right, so let's look at question number 2. All right, so it says a company claims that the average acid level of the water in a local stream is 6.8. Okay, so here's kind of my important sentence right here as I get started. They claim that the average is 6.8. Okay, and as I continue to read in this paragraph, there is nothing here that indicates greater or less, increase, decrease. There's nothing like that. You randomly select 19 water samples. You measure the acid level of each. The sample mean is 6.7 and the standard deviation is 0.24. Okay, I'm going to go ahead and denote this standard deviation of 2.4. They are talking about the sample. You randomly select 19 water samples. The sample mean is 6.7. The standard deviation is 0.24. This is the standard deviation of that sample, so you should use a T. Now, this is a little bit harder because it doesn't say sample standard deviation. You have to read that into it. But in that sentence, they're already talking about the sample mean. So it would make sense that this is the sample standard deviation as well. Okay. All right, is there enough evidence to reject the company's claim at 0.05? All right, so again, there is no word to indicate greater or less. So I'm going to go ahead and write my hypotheses based on that first sentence. The first sentence says that the average is 6.8. So the average is 6.8. That is my claim. It says so in the sentence. A company claims that the average is 6.8. Now again, we've already said this. I'm going to say it again though. You need to recognize that if your statement has an equal sign in it, which this one does, that you just wrote the H0 hypothesis. The H0 always has the equals to. All right, the H1 will be the opposite of that. So it will be not equal to 6.8. All right, that's step 1. All right, step 2, draw your curve. So on an equal, not equal, you should shade on both sides of the curve. So you'll have a section over here shaded. You'll have a section over here shaded. Okay, both sides of the curve. All right, we've already said it's a t value. So I'm going to my other table, the one that says t distribution at the top of the page, and I'm going to look up my value. All right, so what I know is that it is two-tailed. Okay, I can see that from the picture, two-tailed. I've shaded on both sides. Okay, what else do I know? I know that my alpha value is 0.05. They gave me that in the problem. And then my DF is going to be 1 less than my sample size. So I selected 19 water samples. So my DF is going to be 18. So I'm going to take that information and I'm going to go to table F and I'm going to look up the value. All right, so two-tailed, 0.05, and down to 18, 2.101 is what I'm looking at. Okay, so that is going to sit here, 2.101, and then also over here, negative 2.101. And that will take care of part 2. All right, part 3, we're going to use our formula. So remember that the number second in the formula is the same number as we have in step 1. So the 6.8 goes there. All right, the sample mean, they told me in the problem, is 6.7. So that's going to go first. We know the standard deviation is 0.24. We know the sample size is 19. Okay, again, put it in your calculator. Put a parenthesis around the top. Put a parenthesis around the bottom. All right, I get negative 1.82. And again, I always type it in my calculator twice to be sure that I haven't made a mistake somewhere. I would encourage you to do the same thing, because if you make a mistake with the number, then you're going to have the wrong conclusion. All right, so once that's done, then I'm going to mark them off on my curve. All right, so here's the first average, that's 0. The second average is negative 1.82. It's going to be over on the left, but not in the shaded region. So these two values are considered to be the same. They are not far enough apart to be considered different. Remember, the null hypothesis always says they're equal. We're saying, yep, they're equal. So do not reject the null. Okay, and then finally, we're going to use our chart for the conclusion. The claim is H0. We said do not reject it. So we're going to say there is not enough evidence to reject the claim. All right, now, again, this is exactly what you should have, word for word, because it's coming off of that chart. And then you're going to finish it. Okay, so the finishing might be a little different from one student to the next. Okay, that the average, all right, what are we talking about? Acid level. Is 6.8. All right, so that finishes us up on those two practice problems. Again, I would strongly encourage you, work them first, check against what we've just done. If there are questions, email me and ask. You need to be able to work problems similar to this from Chapter 8 for your test. So you've got to practice, but you also need to ask questions about things that you don't understand. Okay? All right, so I'm going to close this. Like I said, let me know if you have questions.